Welcome to the first video on Chapter 5, which is on similar triangles, and we're going to begin with 5.1, which is what is similarity. So when two figures are similar, one is just simply a blown up or shrunken or flipped around or rotated version of the other. So if we look at these two triangles here, basically you can say they're similar if these two are the exact same figure, just this one is smaller than this one. So what it means to be similar is in all shapes basically the angles that match up have to be equal. So angle A has to be equal to angle D, because if you look at the figures, this part should match up with this if this was just blown up. So that means angle C is equal to angle E. Then also angle B is equal to angle F. Now, with similar triangles, if you figure out that two triangles are similar, you can assume that the angles that correspond with the between the two triangles are similar. So you can assume this down here. Then another thing, if you can assume if the two triangles are similar, is so AC, the length AC right here, over the length of DE, which is the side it matches up with. If you were to blow this up, this would be the same side as this, is equal to side AB over DF, which is equal to CB over EF. So basically, if two triangles are similar, then the ratio of the sides over each other, so this over this, this over this, and this over this, they're all going to be equal. So let's say that this right here is 16, this is 10, and this is 20. Then this would have, if this was 8, then this would have to be 5, and this would have to be 10, because 8 over 16 has to be equal to 5 over 10, which has to be equal to 10 over 20. So, and these are all equal to 1 over 2. So the ratios have to be the same, and so if you didn't know what this is, but you had these two, and so you had the ratios here, you would know this is 5, because this, right, you would know this is 5, and then you would know this right there had to be 10, because the 5 over x right there would have to be equal to 1 over 2. So you just multiply, and then you get 1x is equal to 2 times 5. So x is equal to 10. And that's just really simple, and that's how you can find out the lengths of a triangle if you have two triangles that are similar and you have the ratio of their sides. But it's just important to remember the ratio of their sides has to be with the side that it would match up with. So if these two figures were the same size and everything, it has to be, because AC is the same as DE basically, if you would make this bigger, it has to be that ratio. It can't be AC over DF. It just has to be that side it would match up with. And so the way you write two figures congruent is we have triangle A, B, C is similar to triangle D, F, E. Now I'm going to move on to 5.2, which is on AA similarity. And so what this is if you have two angles of one triangle that are equal to two angles of another, then the two triangles are similar. So if we look at this here, if these, let's say these two angles right here, we have these two angles, and it happens that this angle right here is equal to this angle right there, and then this angle right there is equal to that angle, then you can prove by that these two triangles are similar, and so that's called a similarity, and that's angle similarity. And so this is probably one of the most common ways to prove that two triangles are similar, and just by doing this you can prove they're similar, and then all those things that I just talked about apply. So if we can prove this, then AC over DE is equal to AB over DF, which is equal to CB over EF. And if you can also prove that this angle, so if you can prove a similarity, then that must mean that this angle is also equal to this angle. Because if you think about it, you have 180 degrees in a triangle. And so let's say this is x and this is y degrees right here on the inside. And so if you think about it, this angle right here, it's going to be equal to 180 degrees minus x degrees minus y degrees. And that's going to be the same for this triangle up here. This is just going to be the same because this angle is also x, if you think about it, and this angle is also y. So this angle and this angle are the same because you're only left with the same angle. And so now I'm going to do a problem to show you how AA similarity is used. So this is problem 5.5 in section 5.2, and so it asks us to find py, and so this length right here, and wx. So the way you start out is you think, okay, so I have two parallel lines here, so wx is parallel to yz. So because of that, angle z there is equal to angle w, because you think about it like this, it's going like this, so this angle right here is equal to this angle right here. And because these are vertical angles, this angle is equal to this angle, and this angle is equal to this angle, so these two angles are equal, so this is equal to this. So we write down angle W is equal to angle Z. And then you find out that because it's, again, that these two lines are parallel, you can say that angle X is equal to angle Y, through the same way that we just got that angle W is equal to angle Z. So you can say angle X is equal to angle Y. And now that we have two sets of equal angles, you can say that triangle XWP is equal to it's similar to triangle YZP. And so you prove this because of angle-angle similarity. And so you can say that 3 over py is equal to wx over 12 is equal to 5 over 10. So it's, and 5 over 10 is equal to 1/2. So 3 over py is equal to 1/2. So 3 over py equals 1/2. Then you just cross multiply. So py is equal to 6. And you do the same for wx, and you get wx is equal to 6 as well. So just remember, when you see parallel lines, think equal angles because it's important for similarity. Now another important thing for section 5.2 is this idea is you have this figure right here, and line DB keeps going and meets line CE. If you would extend them out like this, they would meet at point A. So if you have that, then what they're trying to tell you is you can say that basically A B over B D is equal to A C over C E. Now, this is explained in problem 5.7, and I'm going to go over that now. So, since we have that BC is parallel to DE, you can figure it out that triangle ADE, the big triangle there, is similar to triangle ABC because of AA similarity, because you can get this angle is equal to this angle, and this angle is equal to this angle, so AA similarity. And so you can say that basically AB over AD is equal to AC over AE. And then what you're going to do here is break AD and AE up. So you go AB over AB plus BD is equal to AC over AC plus CE. Because AE is the same as AC plus CE because that's the whole length, and it's the same for AD and AB and everything. So now what you're going to do is you flip it. So you have AB plus BD over AB equals AC plus CE over AC. Now you can break up, so you have AB over AB plus BD over AB equals AC over AC, and then plus CE over AC. Now, because AC over AC and AB over AB, that's just one, so it's going to be 1 plus BD over AB is equal to 1 plus CE over AC. So you can just say, oh, so I have 1 and 1 on both sides, so just take that out. And so what you can just say is BD over AB is equal to CE over AC. Now, that's the same thing as this, it's just flipped. And so that's the way they did it in problem 5.7, and you end up with this up here. And so they just want you to know that if you have a figure like this and you have two parallel lines like this, that this is what you have to remember right here. So BD, so AB over BD is equal to AC over CE. Okay, so that's what you have to remember. And the only other thing for 5.2 is that with similar triangles, there's a lot of problems with right angles, and so that's a thing to watch out for. And in the next video, I'm going to go over the next parts of Chapter 5.